Go to TAPgiles.com to learn dreams, engage my services, and support the channel. So we've got a position here as our reference vector, and if I just put it down here, then that's at 1, so that's the same, it's matching the scene, and this is up here, and then we wire that into there. So that should be, that's, instead of it being 1, it's 3, because this is way bigger. So if you imagine you've got the arrow going to there, you've got another arrow going to here, and then we put it there, and then we drop down a line to this like line, and it's 3 times the length of this from 0. So it's 3 times along that arrow, 3 times along that graph. So our reference is at 1, so the graph is like 1, each notch is 1 going along here. If you put that there, that's going to be 1, 2, 3, 4, and it's about 4 over there. And if you put it up here, it's still at 4 because it's still dropping down there. If we put this at an angle and still made it have a length of 1, you can see that preview in there. Then we can move this around, and this is an arrow going over here and then dropping down to that arrow. And that's only 0.6 now. And if we move up here, it's an arrow up there dropping down to this kind of direction. So that's 2.7 times where that is. If this isn't at 1, so you've got the reference 1, and that's 2, a length of 2. And the result of this would be 2 on the graph. But then it's multiplied by how long this is. So if one of these is normalized, then it just stays 1-to-1 with what you actually think of in the scene, but otherwise it kind of multiplies them together, so you get bigger and bigger numbers. So this one is 2 away as a length of 2, and this dot product is a length of 2, and they kind of multiply together and you get 4. But what that means is you generally want one of them to just be a direction, just be a normalized vector with a length of 1. If instead I normalize this first, like that, and then wire that in here, then we get something we're more familiar with, because this is normalized, so it's kind of converted to be down there, and then this is compared with it. So now we get 2, and that makes more sense. It's like 2 along this direction. And even if this was over here, it would still be 2 along that direction because of the normalization. Quite often what you want, though, is both of these to be normalized, so that you can just say, is the direction of this that direction? How similar is it to that direction? So you'd wire these in and use vector dot product normalized. So not normalized, it has, like, these aren't at the perfectly 1 length away from the center. So it gives you these big numbers. If you go vector dot product normalized, it normalizes these first, so it just has that direction to that direction, how similar are they, and outputs that. Thanks for watching. I hope you learned something interesting. Go to patreon.com/tapgiles to learn something new every day.